And hopefully I don't give my editor too much stuff to do. All right. All right, let me kick this off. Hi there, and welcome to the Simple Talks podcast. I'm Steve Jones, and I'm here alone today. I don't have any of my co-hosts, but I do have Mike Bowers here from FairCom. And Mike, thank you very much for joining me. But why don't you introduce yourself and tell us a little bit about yourself?
Oh, I'm glad to be here. So, like I said, I'm Mike Bowers from FairCom, and I'm the chief architect at FairCom. FairCom recruited me to come work for them about 6 years ago, um, and the and I've been in the database industry for a long time. I'm on the SQL Standards Committee, for
Okay.
example, and so it's called Insights, but you're in that group is the standards organization, and we do GQL as well as a language.
Oh,
So I'm really into SQL. I've been an Oracle DBA, a SQL Server DBA. I've been an application developer. I've been doing this for over 40 years. So I've watched the industry transform the little before the SQL era, but I pretty much I had a little bit before SQL, but then I was mostly SQL for my whole career until the NoSQL movement. And then I was the data architect for a large multi-billion-dollar international corporation. And so I was part of the NoSQL revolution, went to the conferences, did talks, and advocated for certain NoSQL features and a balance because NoSQL is complementary to SQL. And some of the NoSQL guys say, well, we can replace SQL. That the SQL does things that NoSQL doesn't do, and and NoSQL does some things that SQL doesn't do. So they can be
yeah.
complementary. But the real problem, the dirty little secret in the whole industry is you don't want to get two databases. You don't want to have SQL and a JSON database. That's two databases. That's nightmare for everything. Nightmare for administration. Nightmare for getting consistent data. Nightmare for even just synchronizing your data. The whole story is a nightmare. So you really need a database that can do multiple protocols. You need SQL. You need some NoSQL features. You need JSON, and Postgres does a pretty good job of blending some of those things.
Right.
Um, but there's features that Postgres doesn't have that you need in a JSON database as well. So there's and then there's other kinds of as I grew in my skills because we had all the database flavors in my last job that you can think of. You name it, we had it, and because we had thousands of developers in the group, and I was the data architect for all of them. And so they would come to me, well, we want to try out this database, and
Yeah.
and so I had to research all of them, become an expert in them. So I know pretty much every major database on the market and how it works and why you would use it, why you wouldn't use it. And I had a lot of fun with that. That's why FairCom recruited me because FairCom was an ISAM for years, just only an ISAM database, which is
Yeah.
a which is an old NoSQL technology that predates the SQL databases. In
Yeah. Right.
fact, I yeah,
Let me just say,
yeah,
why don't you just describe what ISAM is for people? Because I'm sure there's plenty of people who have never worked on a mini computer, right, a VAX or anything else. So
yeah,
they don't know what ISAM is.
yeah, totally. In fact, it was only really early in my career when I first discovered ISAM. I was a consultant, and I went to a gig and in Georgia, and it was a newspaper thing, and they said fix this C code, and it's using this C tree database, which is an ISAM database, and that's the product Faircom had, and it was Faircom's product. It was the only time I really used Faircom, but it was early in my career, and I never used it after that until now. But I went, what is this thing? And so all it is, it's called indexed sequential access method. IBM invented the term, I believe. Um, and just a little secret in the industry, all the major SQL databases are built around it. They built
Yeah.
SQL on top of ISAM. DB2 is completely built on top of ISAM. So is MariaDB and then its predecessor. Well, I shouldn't call it predecessor, MySQL.
MySQL, yeah.
Yeah, they're all built originally on ISAM. They changed out later for other kinds of engines too. But ISAM means you store your record. You have records in a table, and those records are indexed, so that's nothing new or special. But um, the fields are less important. There, it's actually you're indexing segments in the binary buffer. So a record is considered like a bunch of bytes.
Yep.
You just have a bunch of bytes, and you just say from this position 4 to position 12 is an integer. Index it, and um, and then later you can add fields. And so ISAM doesn't even think about fields. You're just indexing a buffer, and
Yeah.
you bring that buffer in to your application directly. So you have no layers. You don't have SQL optimizers. You don't have SQL parsers. You don't have any of the cool things that SQL can do either. But it's so low level, bare. It's pedal to the metal, extremely fast.
Yeah.
And so a lot of companies will use ISAM if they write a C application, particularly because you can't get faster than that.
Right.
And for example, the entire stock market today is run. They have other databases there too, but they track every stock market transaction in the FairCom database because of the speed. And at night, they do analytics on all the data they collect, and then give that data to all the stock market analysts. The company that does that won't let me name their name because this FairCom is one of their secret sauces
Right.
because we're the only database fast enough to not only gather all the data in real time and store it, but then at night do major analytics on that data so they can get the next day, turn it around and get it back to all the stock market analysts in the world. Um, so that's a use case where SQL is not fast enough.
Right.
SQL cannot perform at that level of speed, but you have to write C code, to do that.
Yeah.
So that's ISAM in a nutshell. But people aren't writing C very much anymore.
No, no. As a matter of fact, right, they're even
Yeah.
trying to get out of the C world and the operating systems, right? Like Rust has become the big new thing for
Yeah.
Linux or even Windows, right? What they're saying. Because C, right, like it's amazing, it's fast, but it's hard, right? It's easy to make
Yeah.
mistakes. It's tedious and it's slow. And the same thing for me. Like I remember you're a little older than me. I've been, I think, doing this for 35 years in the database world, but having to write C code to go, and retrieve ISAM records,
Oh,
because you're like, I'm just really retrieving records off disk, right? I open a file and I'm just yanking stuff and putting it back and saying, hey, there's an index. I need this stuff. So it's been a long time for
yeah.
me to do that.
It
Interestingly,
is a
though, like
lot more code. You're right. It's a
it's a
lot
lot
more
more
code.
code, right? So I've never heard of FairCom. So can you tell us just a little bit about the company, like where? I guess it's been around a long time if they're just in the ISAM world.
Yeah. So it's 46 years ago. I'm 46 and a half now, almost 47. Actually, our anniversary is coming right up in September. It'll be
Okay.
47 years. We started out as a library to add to your C program. So it was literally a library. You could buy it for $250 and
Okay.
and have a royalty free. And in
Okay.
fact, we still have customers all over the world who are using us royalty free on our early versions because it still works. It was just really good code, still is really good code. But originally we were just a C library. You would add it to your C program, and now you could open up files, put records in files, index them, and get
Okay.
data in and out super fast. And but over
So
the years,
so no
go ahead.
server process at that point, right? That's
At
just
that point,
in
yeah,
process with your app.
in process, and not even a not it was you compile it into your C program. It was a
Right.
C
Okay.
library. You got the source code, open source,
Yeah.
basically, other than you paid 250 bucks to get it. But no royalties or anything. Well, that wasn't a good business model.
Right.
And we evolved very slowly out of that model. We eventually turned into, about 20 years ago, a server model where we have a full blown server. And at that time, our customers also wanted SQL. And
Okay.
we didn't just, and just to be clear, we didn't just stay with ISAM. We evolved ISAM. ISAM was very primitive in the beginning and simple. And our customers for decades have kept asking for more and more and more features. And so it actually has grown into very powerful, but of course that means it's more complicated too,
Yes.
at the ISAM layer. So then we wrote API on top of it. We call it the database layer, and it's a relational database model layer on top of the ISAM, but we kept it really fast and lean. So now you can do relational programming on top of the ISAM engine without the complexity. You can keep it simple. And our customers wanted more, of course. And then
Right.
they said, we want SQL. So we built SQL. So we have a SQL engine running on top of that database layer, which runs on top of ISAM, but it's very lean. So it's very fast SQL, fast ISAM. So you can have ISAM and SQL on the same data at the same time. So what that means to you is if you have you when you build a normal application, you want SQL because SQL can join data, SQL can filter data. It's
Yep.
ad hoc, it's super powerful. I love SQL. It's a fantastic engine, or fast language and paradigm, and I love the relational model. Um, but when there are things it doesn't do well, and there are things that ISAM can do that SQL can't do, and especially when you get down to that performance. So a lot of our customers do, they'll use the SQL for the general purpose things, for productivity, for developer productivity and compatibility. We're ANSI SQL compliant. So anything you write in SQL Server or Oracle. Well, Oracle has a little different SQL syntax,
Yeah.
but SQL Server, Postgres, we work really well with, and Oracle too, if they're more standard syntax. Then you write that in SQL, and then you go when you have a performance oriented task, instead of writing a stored procedure which is not getting you low enough, you can write the ISAM and go all the way low. But you don't have to use C. We have drivers for ISAM for Java, for C Sharp, for Visual Basic, for PHP, for Python.
Okay.
And so you can get that kind of performance, um, the ISAM level performance in the language you like. And so you could write, say, a Java program that does some batch processing at this lower API at super high speed, and at the same time have SQL running on the same data on the same data simultaneously while you're doing this, and there'll be
Right.
no problems. So you can
Oh,
have the best of both worlds on the same data at the same time.
wow.
Um, so that's been FairCom's claim to fame. But as you pointed out, people really want to more JSON oriented features
Yeah.
nowadays. And so that's when they hired me. So then I brought in the JSON API, which is actually simpler and easier to use than Mongo. I made a real big point in designing this to be easier than Mongo. And of course, we can get faster because we have that low level engine under us.
Right.
And so we have easier API, very capable JSON API over the same data as SQL and ISAM simultaneously. So you can do JSON, you can see your SQL tables as JSON without even doing any work. You don't have to translate it. Just the whole table record is JSON to you. And you can put JSON in, get JSON out. And as far as SQL goes, it's columns, and
Right.
it sees things as columns. And as far as ISAM goes, it's just records. So you can work with JSON as easy as SQL, and SQL doesn't even know you're doing it. That's the cool part.
So it's really you've got you're storing the data once, right? It's stored as ISAM
Yeah,
files, and then
yeah,
there's a SQL engine that can read or write to that, or a JSON engine. Um,
yeah.
that's interesting. I haven't heard about it before. Hasn't caught on. I assume you have lots of customers, right, across 40 years.
Oh
Faircom's a
yeah,
big customer. Well, so let me say, how big is Faircom? Like, how big is the company?
yeah. Well, we're privately owned, so the owner won't let me give hard numbers, but I'll
Okay,
I'll just
fair
give
enough.
you some examples. We have big customers all over the world.
Okay.
We have offices all over the world. And for example, Verizon is one of our customers.
Hmm.
Ford Motor Company is another one. Commvault, the backup software, is another customer. We're in their international space station running it. We're
Oh,
in
really?
the yeah, we're in the and we're in the European Union also has their space station. We're in that too, and
Okay.
then we're in at the FAA. Every flight in the United States is tracked in real time in the FairCom database.
Oh,
Um, we're in the number one 911 software that you make a 911 call in the
yep.
U.S. We're this database that runs all that.
Wow.
It's installed locally in every city, so it's not one database for the whole country,
Right,
but
right.
yeah, we're the product. And by the way, they started out with our ISAM. They wrote their program in Java,
Okay.
and so they used ISAM. But then there's you get the speed, but it's not as you're dealing with you know record access. So you're
Yep.
writing more code.
Yep.
So now they're using they use SQL too, And now they're using the JSON API that I designed. And they're really loving it. They're loving the JSON because you get more productivity, even in SQL with the JSON. So JSON takes you to a new level.
Yeah.
And you're not, and by the way, in my JSON API, you're not giving up SQL because in the JSON API, you can write SQL queries and it'll execute the SQL query and return the results as JSON. And
Okay.
so
Yep.
so you have all the power of SQL with joins. As you
Right.
know, I love SQL. So
Yeah.
you
Yeah.
get
Yeah.
all the power, but it's all JSON. As far as your application is concerned, it's JSON, and that makes your application more productive. And you don't even need a driver to do this JSON because you just post JSON to our endpoint, and we give you JSON back. And applications know how to work with JSON.
And you're
So
HTTP, HTTPS, right? For the endpoint.
yeah,
Yeah. Okay.
exactly.
Yeah. I
Yeah,
mean, I think I've seen that more and more. Like, so most of my audience, most people that know me, I'm a relational guy. Most of the people I think probably listening to this would go, well, SQL's easy. Like, just write SQL and consume it. But
yeah,
as I work with more and more developers, they're more comfortable serializing and deserializing JSON to do
yeah,
work, right? And even Microsoft, like they built the data API builder for that reason, because developers want to get and post JSON and deal
yep,
with results that way, right? Because in C Sharp or Java, I think it's easier to work with JSON than it is to work with a tabular thing, right? Depending on what
yeah. It
language you're
is
in. Most people are
definitely.
comfortable, and I think you might remember this. I think around the turn of the millennium, a lot of people thought XML would do that. Like a lot of people were writing XML,
Uh-huh.
but
Yep,
buying an XML parser and redoing XML felt harder than JSON.
for
I, I,
sure.
I'm not sure why, because maybe it's not as dense as JSON, right? Because I have all the tags, right? Whereas
Uh-huh.
JSON, I just have brackets and braces and things. But
Well, in XML, I became an expert in XML too, and XML has attributes and nested elements.
yeah,
And when do you use which? And
yeah, there's no good
and
standards,
it's
right?
so
That's why you had to have
confusing. Oh,
a schema document to kind of explain. I remember
yeah,
doing EDI
yeah,
stuff, in the
yeah,
90s and trying to parse that and pull it together and get it to SQL or out of SQL and back. It was just a mess. And
yeah. JSON converts much nicer. So what I did
yeah,
is I said I built a JSON layer on top of our SQL. So you run a SQL query, it returns records, but we automatically convert those records into JSON so that so the developer technically doesn't even have to understand SQL. Or they can use SQL, but they don't have to
right,
understand columns and they don't have to understand how it's stored. They just think, oh, I'm running SQL on JSON.
right.
That, for as far as they're concerned, that's that simple.
And they just deal with JSON documents then, which
Yeah.
I think we know, right? Developer productivity is huge. And while, right, obviously ISAM is the best performance, but developers aren't as productive. I think
Yes.
for a lot of us, SQL is ubiquitous. I don't know how we get away from SQL in many ways, but it
Right.
definitely can be slow for developers beyond simple CRUD stuff,
Right.
right?
But you need it. You need joins and you need all the
Yeah,
filtering and so what I did is I merged the two. So now you have SQL and you have JSON, and it's not hard. It's super simple. Um, yeah, I wish I could like show the customers right now
yeah,
and
yeah,
or the podcast right here on the because you can see their listeners who just see, oh my gosh, that's all it is. It's
yeah,
just a tiny little simple JSON statement, runs SQL, returns JSON, and you just
yeah.
use it. And it's like, wow.
Yeah, we,
And
we
then
we might have to get an article or something, or get somebody to test it and just do some experiment and show some things, because that certainly would be interesting to see. All right, so let me go in a slightly different direction. You have embedded databases, right? I assume they're both in process and out of process at this point with applications, but you also have just
yeah.
a server product people set up. How do people typically architect and set that up? Is it is it its own OS? Is it big,
Oh
small?
yeah.
Right? Like, how does
Oh
it
yeah.
work compared to Oracle, SQL Server, Postgres, whatever?
Yeah, well, in installation is real simple. You just you can we have normal installers, so you can use those, but you can also just unzip and run it. So
Okay.
we everything's precompiled, ready to go. Um, so that's and you can run as many instances of our server as you want on one computer. And that
Okay.
other, usually SQL Server and Oracle, you get one instance per computer, right?
Right.
One per server, and that's why people use VMs or they use containers so they can run multiple instances on a computer.
Right.
We run in containers, we run in VMs too, of course, but you don't need to because you can just unzip and run us as many times as you want on the same computer, and we play nice with ourselves on the same computer.
Oh,
We don't conflict.
but
We have
we
to
have
change
different
port
endpoints then,
settings.
right? We would just pick a different port for each one. Is that?
Yeah,
Yeah,
exactly.
that's
That's
simple. Okay.
exactly it.
How
Yeah.
about like resource usage? Like if I compare this to a SQL Server in Oracle or Postgres, uh, let's say, I want to run a typical transactional type system. Let's,
Mm-hmm.
hundreds, a few hundred users, right? Let's say a terabyte of data because that's a nice round number. How big, small, like how much memory disk kind of stuff? How does that work?
Oh yeah.
Com?
So we do scale from to very large. We have
Okay.
customers who are running 500,000 transactions per second for real on
Okay.
one high-end server. So that's kind of, and they're running several terabytes of RAM, and they're running many terabytes of data. I don't remember how many terabytes of data, but it's a lot.
Okay.
And so they're running that. We're a transactional database with
Okay.
true transactional asset support.
All right.
Um, and so we can scale to that level on a single computer. You don't need to go to like these, multiple computers and big clusters, which actually slow things down.
Right.
We are fast on one computer, which saves you a ton of money. And
Right.
then, but we can also be very small. We can run on a Raspberry Pi,
Oh, wow.
literally run on a Raspberry Pi, and in a small Linux server like that, which is or Linux, Raspberry Pi. So
Right. Right.
we
Right.
could, that's the range, and you can control. We auto scale our memory usage. We also give you lots of control over that because we have customers who embed us and they need full control. So you can
Right.
control how much memory we allocate to buffers. Now you can do that in other databases too, right? It's not magical,
But small is
but
often a
we do
problem.
give you
Like,
absolute,
right, small can be a challenge
yeah,
with SQL Server, Oracle,
yeah.
maybe Postgres.
But we can
MySQL, I
go
know, can go
small.
small. Yeah. Huh.
Postgres really can't go small. Yeah, we
Yeah.
go smaller than them all, but we can go as big as any of them, um, and handle the throughput and high velocity. And the other thing is predictable latency. That now, when you're using SQL is SQL, so you're
Right.
not going to get predictable latency on SQL because you have all those SQL layers with
Yep.
parsing and you know all that stuff. But ISAM, you get predictable latency. You can guarantee with SLAs how fast you can insert a record, get a record back, and so our customers love that predictability of our product when they need that. And so for example, in Europe until recently, until like 2 years ago, Visa Europe was run on the FairCom database server, doing
Okay.
400,000 transactions per second. And that was a different example than the 500,000 I was talking about earlier.
Right.
And every time you swipe a Visa card, it was going to the FairCom database. The only reason they got off of it was Visa US purchased Visa Europe. They were separate companies, and they just merged all operations to California, and they had a whole different system that
Right.
they were doing. So, um, but yeah, that's the kind of scale we run at
Huh.
on a big end, high end server. But if you need to embed us in a dental app, we have one customer of ours is Dentrix, and they sell and another one is the 911 solution I mentioned earlier. Motorola sells that, and we're inside the application as an embedded database, and we run on some very small hardware.
Right.
So we
Huh.
built the engine to auto scale from tiny to big without you having to do tons of work. Oh, and
Interesting.
the other thing that's really cool to do that, because we're embedded, you don't put DBAs in an embedded product, right?
Right. Yeah, you don't.
The application has to work whether you have a DBA or not.
Right.
Your dental office doesn't hire a DBA,
No.
that, right? Your 911 police station doesn't hire a DBA.
Right.
So we built a database that requires very little DBA administration. We
Okay.
self-tune our indexes. We self-tune the tables. We reuse space automatically. So the engine itself keeps itself running beautifully without a DBA. Now, where of course DBAs are valuable because for development, right? If you have expertise in knowing how our JSON API works, how SQL works, for development DBAs, absolutely. But administrative DBAs, you really don't need one for the FairCom database.
Interesting. So you self-tune indexes, people don't create indexes. I assume they
Well,
create
we,
some
well,
sort
we
of,
do no, but we do create
you
them.
do
People
create
create
index.
them, but we keep them tuned.
Okay.
So like in Oracle, when I was with DB and Oracle, I had to go. One of the nasty secrets people don't like to talk about with Oracle is the tables get slower and slower, and the indexes get slower and slower because Oracle doesn't clean up what you delete.
Right.
And when you do inserts and overflow the record size, it basically is deleting and inserting somewhere else. And so you've got all these holes, and it loves full table scans. And there's good reasons why it should. But with all these deleted records, it's slower and slower and slower. So you
Right.
have to write compact routines. So, and every kind of table, index organized tables, regular tables, they all need different routines to compact them. And indexes are the same thing. You have to rebuild indexes. They get slower. They don't keep them tuned. And so you have to rebuild those. And DBAs are needed to write all this code to keep the database running well. Um, and that's why DBAs are needed. And
Yeah.
if DBA is not doing that, their database gets slower and slower.
Huh. So let me ask you this on disk then, if I have a server product, do DBAs, is there administration in managing files, or you just write to, do you self-manage files and structures? How does that work? Do you need raw disks like Oracle? How
Oh
does
yeah, just you
FairCom?
just give us. In fact, we're really flex. We just run on the operating system, so we're
Okay.
simple. You just lay us down, and we'll write files to the operating system. We don't even we're not block based, so you don't have to worry about aligning your blocks or all the things you have to do in Oracle to make it perform well. We literally just allocate file space. We open a file,
Okay.
allocate space, write records to the file
Okay.
at that level. We use the OS level, and we did that because in the beginning that's all you could do 46 years ago,
Right.
and you didn't have low level access to the hardware, and the hardware was not defined back then.
Right.
It was still being invented. Um, but what also makes us portable across every operating system. We can
Okay.
run on really obscure operating systems that no one does, like QNS and other kinds of things. And we actually, at one point, we were ported to over 124 operating systems.
Oh, wow.
As crazy as that goes. I mean, of course, we
Yeah.
run on Windows and Linux and Mac today,
Right.
and all kinds of flavors of Unix, but we can run a lot.
But I've seen
Uh,
like OS 400, ZOS, all that stuff. Right.
yeah, we could run on just about anything in the day, but no one needs that today. So
Yeah, no. I think it's
um,
Linux,
yeah,
Windows, and Mac at this point where for almost everything, which is kind of
yeah,
amazing to me. It's kind of amazing how that's
yeah.
changed. So,
It's definitely simplified things for all of us. That's good.
yeah. All right.
But
So,
because we write to the file system, we don't have to worry about low level things
right,
that actually cause trouble. Like in Oracle, you have to worry about what kind of storage you're using, and are you
right,
using, NAS or SAN, and how it's attached, and how it's organized, and how it's formatted. We don't care. It's
right.
an operating system does, and we still perform fast. We've tuned that on every operating system to be just as fast as Oracle is with their block level storage, without
Huh.
being block level.
Oh, that's very
So,
interesting. Huh. Okay. Let me ask you this. What about backup recovery, right? Like if I've got multiple terabytes in FairCom DB, how do I ensure, right? Because machines fail, hardware fails
oh yeah,
rarely, right? But it fails.
it does. Yeah. Yeah, we have backup and recovery just like every other database. We have a backup utility that you can run backups. We do point in time backups and restores.
Okay.
So just what you would expect out of a backup solution.
Any idea how does that compare to SQL Server Oracle? Like can you say anything about how fast it is? It's similar, I guess.
Yeah. What my favorite is we support snapshots because we work at the OS level in the file system.
Okay.
We have a quiesce feature, and then you can take a snapshot using no matter what storage system it is. Take a snapshot, and that's faster than backups. And then you can restore that snapshot. And we're just like Oracle, you could pull the plug on us at any moment. We have transaction logs, and we will come back up and not lose data.
Okay.
So we're very durable. So you could easily do our big customers use snapshots instead of backups, and because it's so fast and efficient. Because
Right.
the bigger when you have many terabytes of data, backing up no matter what you do takes time to move all
Yeah.
that data, right?
Yeah.
And of course, we have incremental backups. We have all the tricks that everybody else has.
Okay.
But my favorite, I just want to point out, we have the snapshot feature, which I just love. Um,
All right. What about I'm just thinking, the typical things we do in the database world. Security, how do you manage RBAC or role,
Yeah,
login,
we
right? Like,
have
how does that work?
yeah. So we have our back.
Okay.
Um, it's a new feature. We didn't have that before I came on board. I designed a new RBAC system for FairCom DB.
Okay.
And what I did, it's your traditional RBAC. It has roles and accounts, and you assign roles to accounts, and then you assign privileges to roles.
Right.
So nothing is surprising there. But as a DBA for decades, what drove me crazy is that when you add roles to an account, you have to be really careful because if I add a role that grants users extra features,
Yes.
extra privileges that I didn't expect, or worse, I grant them one today that has the privileges they need, but tomorrow somebody has more privileges to the role,
Right.
and I don't even know the user has more privileges, and I'm opening security holes.
Right.
So what I did in our RBAC system, I added a feature that you could ban privileges from a role,
Oh, okay.
which is not normal. And mostly you just add privileges to a role. If you
Right.
ban a privilege from a role, it means that no matter what role is added that has that privilege, it doesn't matter. It's banned. So I
Yeah.
can guarantee you will never have that privilege, no matter what other roles might accidentally or intentionally give it to you.
Yeah.
So we have that feature, which I really like, because now you can have certainty in your RBAC that this person will never be an admin. I'm not letting Crazy
Right.
Joe in there, no
Yeah.
matter what.
Yeah. I
So
think SQL Server has some of that, but there's limitations. Like I think you could create a custom role and give people lots of rights, but ban backups or create database or right different things. I think it probably
yeah,
works better in the lower levels than the higher levels, but still. Okay.
yeah,
Uh,
yeah.
Interesting.
And we
Replication.
do, yeah, we have replication,
Okay.
and we have a really cool feature that a lot of other databases don't have is so we have normal secretist and asynchronous replication, and we
Okay.
can do failover, and we can do like SQL Server always on kind of failover, and we
Yep.
can be shared nothing, or we can be shared everything. So we have all those capabilities. The cool thing about replication is we have a feature that can do data change streaming,
Okay.
and so replication in traditional databases like SQL Server is you can replicate between the same kind of database. If you're SQL Server, you can replicate to another SQL Server
Correct.
database, right? And so FairCom does the same thing. You can replicate to another FairCom database. But what if you want to get data out of FairCom database and send it to your ERP system,
Right.
or you want to send it to Oracle or another system? How do you do that? Well, you could purchase Golden Gate and pay a fortune,
Yeah.
um,
Yes.
and or I mean, literally a fortune,
Literally a fortune. Yes.
unbelievably expensive. Um, but with Vericon, what we do is we can send a data change stream to our built-in MQTT server. So we built
Okay.
in message queuing into our product. And now, when data changes occur, inserts, updates, and deletes, you can stream those changes as JSON messages to our MQTT server, and it will publish those to topics, and you can subscribe. So you can subscribe to a live data feed and get
Um,
all the insert, update, and deletes. I mean, you get before and after images too of the data. So you could do full replication
right.
to any system that you want to go to out of our product. And if streaming, if your velocity on your inserts and updates and things is so rapid that a message service can't keep up,
Right.
because messaging is more intensive, it has handshaking and it's got
Yeah.
more overhead. We store it in our messaging server is a database, and it's tightly coupled so that every message that comes in ends up in the database. So now you can, like Kafka, you can come back and read all the records
Right.
on your table, and you can bulk read them, which is way more efficient than getting things onesie twosie.
Right. Right.
And so you could bulk read hundreds of thousands of records in a batch, and in a single request, and get that data at high speed out, and then replicate it into your system, whatever it is, any kind of database, any kind of application.
Right.
So Verizon is doing that. Verizon is we have they're using our database as their core high speed engine. So when you make a phone call on Verizon, the all the whether you're authorized to make the call metrics when you start, when you end, how long you talk, the billing, all that stuff's tracked in real time in the FairCom database. They're originally used ISAM for that. They recently have upgraded to a microservice architecture in Java, and they're using our JSON API to do what they did in ISAM and C originally, and they're really happy with this solution using JSON because their developers way more productive, and and they're still getting the performance they need. And so they're really happy with that. But they needed to get data out of our database replicated to the caches in their microservices. And they were using a Java library to be their cache. And so it didn't have connectors to any databases or anything.
Yeah.
So what they're using they subscribe to the data stream coming out of our replication.
Out of curiosity, I assume if I'm doing, this pub sub type stuff, I have ways to manage that, right? To age it out, delete, clean up older stuff, set a lifetime, is that kind of stuff? Because, right, data size is always a
Yes,
concern, right?
yes. Yeah, so we have retention policies on our
Okay,
tables. So you can say basically it's partitioning, but we refer to it as retention. And so you say um, I want to retain 14 days worth of data.
right. Okay,
And so it would age out every day and so you'd always have 14 days on hand. And when a new day come, you drop the old table and old file and get the new file created automatically. It's
yeah,
transparent to you, but
yeah.
we're yeah, partitioning.
Interesting, interesting. I mean, it definitely sounds. I'll have to take a look at FairCom. Like, I'm just curious now how many people are using it. I know from our side, we see lots of customers co constantly adding new databases, and I'm sure you've seen this, right? Like, now I have this huge knowledge gap that I have to be training different people on how to work with this database. How do we manage it? How do we
Yeah.
tune it efficiently? All my developers as I move projects now, I may or may not have similar connectivity methods because, right, drivers change, language changes, right? So
Oh,
SQL,
yes.
PG SQL, PL SQL, T SQL, they're all different enough that they cause problems for people. So I certainly think the future of working more in JSON makes a lot of sense for a lot of applications. All right, see that. Um,
Oh, yeah, and you reminded me about stored procedures. We have
yeah,
a built the Google V8 engine is the JavaScript engine is embedded in our product. So now we have JSON being processed with stored procedures in JavaScript, which is a match made in heaven. JavaScript,
I,
JSON,
I guess
and
I hate JavaScript, but that's what
yeah. Well, I mean, it's not my favorite language, but it's built for JSON, right?
it is built for
Um,
JSON. Yeah.
and
So
you can Google it, and AI knows how to. You just say, "Hey, AI, create me a function to blah," and
you
it'll
could,
do
right?
it.
Yeah, yeah.
It does that now. It's crazy.
So,
So,
so let's talk about are you guys adding AI to FairCom DB? Is AI on your
yeah,
agenda?
it is. So one of the things we're doing is we have built into our tables this concept of messaging. So
Okay,
we call it. We have a special table for this because it has extra capabilities. We call it an integration table. But what you do is you can publish messages to it through MQTT and publish, and then you can customers can subscribe and get the messages out. All the messages come into the table and are stored in the table. The where AI comes in is we have transformations built into this table. So you can have a transformation pipeline. You could think of it as a stored procedure,
okay,
um, but it's simpler because it's a pipeline and it's configured through JSON and it runs JavaScript. And also we're building now in trained machine learning algorithms into that. So you could take records that are inserted, run them through a pipeline of transformations that include machine learning algorithms
okay,
and enrich the data. So take, for example, let's say I take a picture and I insert it into a table,
right,
or I post a picture on MQTT of a message and it ends up in a table, in a record. Our pipeline could take that image and using trained algorithms, it doesn't matter how you got them trained. We have a universal library that could take the vast majority of algorithms that are trained and we can run them in the database. And so now you just say, I want to do sentiment. Is this a or tell me what's in the picture. It'll tell you, oh, there's people here. There's
Right.
three people in the image. If it's trained on who they are, it'll tell you who they are. It'll tell you if there's animals, objects, it'll tell you what's in the picture. It'll even tell you the sentiment. You have algorithms that'll tell you if they're happy or they're angry. Um,
Okay.
you name it, it can tell you what's in those pictures. So you just take whatever trained algorithm you need. Let's say you're interested in counting dogs in pictures,
Right.
and the algorithm does that. It'll just then automatically count the dogs, put it into another field in the record, and say two, because you'd have a dog count in the
Right.
dog count field, and you
Right.
just put two in there, so you can add as many of these algorithms as you want to a table, and when records are inserted, they'll run them all and enrich the data on the table right there.
Okay. So that's interesting. Like that's what we're doing with a lot of our products is more of the um, computational type AI as opposed to the Gen AI large language
Yeah,
model stuff. Because I think that sees a lot of value. Any Gen AI plans with that? Because I think that's everywhere these days.
yeah. Oh, it's so cool too. We are looking into code generation.
Okay.
So and that's where the JavaScript's a good example, because that's where Gen A is good.
Yeah.
Gen AI can generate JavaScript in its sleep.
Yeah.
And so we run JavaScript server side, and it's Google V8. So it's compatible, 100% JavaScript compatible with
Right.
everything. So it's easy to go and enrich have Gen AI create your code and do anything you want with it, with your data. Um,
Fascinating. All right. So FairCom DB sounds interesting. I think people should check it out or look at it because I certainly like the idea of less database platforms and less management there. Let me ask you a little bit just about SQL because I've primarily been a T-SQL person, right? I've done some PG, some PL, other things. Um, I see some products with ANSI SQL, right? BigQuery, some of the Google stuff, but uh, how how hard or what do you think about ANSI SQL versus some of these other ones? Pros, cons, as somebody that works with standards, how do you view that?
oh yeah. Well, SQL is a funny standard because it's the most non-standard standard I
Yeah.
think I've ever worked with.
Yes.
The because it was designed by committee, and the vendors were the committee. So Oracle has been huge. I don't know if you're not on the Insights committee, which most people aren't, right? There's only a handful
Right.
of us that are on it. I mean, and you're not barred from being on it. Your company can pay and you can join, and there's a lot of work involved. But Oracle Dry has driven that whole process.
Okay.
And they're the least compliant to the standard of all of them, actually.
Right.
Um, I
But I
mean,
think they're always trying to
because
add little pieces to the standard that they want, right? I mean,
they
Microsoft,
are
I know,
absolutely, yeah. Microsoft, Oracle plays the committee game and they
right?
add pieces to the standard. Microsoft is not much involved in the standard.
Okay.
They're kind of bystanders. They kind of do their own thing, and then when the standard comes out, they kind of compromise their thing in the standard, and um, so they're the
Huh.
but Microsoft is pretty antsy standard, but there's so many like JSON, Microsoft JSON and Postgres JSON. They're not the SQL standard,
No,
and so
no.
the
Well,
SQL standard didn't get adopted for JSON.
yeah, I
Frankly,
think
not
it's
much. I mean, a little
it,
bit.
yeah, they're not sure what to do, and so they hack something in. Like I don't know
Yeah,
as much about Postgres, but certainly with Microsoft with SQL Server, they're hacking in like Graph, or they
yeah,
hacked in, Apollo, and they try to hack in the JSON stuff is very hacked. Like it's clunky.
yeah,
Yes. Yeah, it's
yeah.
interesting.
And
I know.
Postgres did the same thing. Really,
Yeah,
Postgres came up with their own JSON solution, which is not bad, but it's still not
it's not
yeah,
good. Like,
not well designed. I would
yeah,
say, like you said, hacked in versus somebody with relational modeling theory sitting down and going, how can we make a complete design that would really work? And that's what I did for FairCom DB. Um, I did that with our JSON.
right,
And by the way, Oracle recently just released a new JSON flavor that is similar to ours. They didn't copy me. I don't, maybe they did. I don't know, but I'm not going to claim that. But I didn't copy them. I could promise you that. I predated them. But
right,
yeah, its idea is that your top level fields in your table become your top level properties in JSON. It's not a complicated idea.
right.
And there's a direct one-one mapping. And if you have nested properties, you could have a JSON field. and your
Right.
JSON field is the top level, and it could have any nested you want in it. That simple model is what we do at FairCom, and it's amazing the mileage you get out of that
Yeah.
without having any complexity.
Huh. Interesting. Yeah, SQL lends itself to a lot of things. Like I both love SQL and I think it's a horrifically designed language in many ways. Um,
Yeah, right. By
like
committee.
well, but if you were a C program, right? Like if I go,
Oh yeah,
static void something, I wouldn't write alter static void to create a new version of something, right? Where SQL,
right.
our DDL is very, from a language standpoint, it's very weird, right? From a version
Yeah,
control
yeah.
standpoint. And then similar things with, for most languages, as we try to do in IntelliSense, it's, I create a function and I do some things. And in SQL, we kind of say, here's the things I want. Now here's where they are, and now here I'm going to qualify it. And then I qualify it in a different way. And at the very bottom, I order it. And we don't process in that way. So it's
Right.
right. If you step back, it's a very weirdly designed language. Um, at the same time,
Definitely.
it, it's so flexible and right. Once you get used to it, I think it's very powerful. But from a
Yeah,
language
I do
tooling
love the
standpoint,
language,
yeah,
but it's declarative, right? And so
yeah,
it's not an imperative or command language like do this, do this, do this, and
right,
you know what order it happens. You're saying, "Oh, I want this.
right,
Can you do it for me?"
yeah,
And that's why the language has to parse it and then optimize it and figure out how am I going to do this.
yeah, just
Where I think SQL went crazy on me was when they started embedding SQL statements inside of the select clause, and you can embed entire SQL statements. Of course, in the from makes sense, and then you're starting to
but you could put it
correlate.
in the column list or the where, right? Like you could put it
Yeah,
anywhere. Yeah,
and then
that,
all of a sudden values both have to match up, and you can do some crazy that it just started getting like wow.
yeah,
Um, it
yeah,
got really complicated. So XQuery was an attempt to solve that. And I became really good at XQuery for a while when
right,
XML was hot, and I worked with an XML database called MarkLogic quite a bit, and they use XQuery. So I became quite good at that language and that paradigm. And it's a functional language, and it's not imperative but it's functions, so you can they're cousins. It's
right,
the point I'm trying to say is you can control a lot more in XQuery than you can in SQL. But because it was pure functional language, that was even weirder than SQL. And
yeah,
no one it did get very well adopted in the industry, unfortunately, but it did solve a lot of problems that you just described.
right.
So we're still waiting for a real programming language
Good.
for
Yeah, yeah,
data.
yeah. What about, let me ask you this real quick. Have you done GraphQL at all? Have
Yeah,
what
yeah.
do you think of GraphQL versus SQL?
Well, GraphQL is more of a it's not I like SQL better because GraphQL is not a query language for data. It's a API language
Yeah,
for running functions. So GraphQL, you can have a schema and you can say, okay, here's what I want you to give me back.
yeah,
But then you're really calling a function that's been pre-canned. A developer's created a function that does something, and then you're saying, now I want you to give me back this data through this function. It's not as generic as SQL to me,
it's not as generic as SQL, but it does have some uh, structure-wise. It feels m- like it might create more productivity for developers than SQL, but
it can, and developers like it. But
uh,
when you write a GraphQL backend, because you have to implement a backend for GraphQL,
right.
because it's not a standalone language. You have to map all those query things that are coming in to functions and basically select statements, and you have to go generate all the SQL code or if you're NoSQL, all the NoSQL code
Yep.
to supply to resolve the query. So really, it's a back-end developer doing all the work. Sort of reminds me of the Wizard of Oz. You got the wizard in the closet doing all the work, and it just looks really easy on the outside.
Yeah. I will say the data API builder for Microsoft, which works on SQL Server and Postgres,
Oh yeah,
they do all that stuff for you. So you essentially add
yeah, that's cool.
entities or add procedures or functions and say, expose these in my API, and it makes it easy for
Yeah.
developers to create that stuff. So interesting.
Oh, very true. Yeah.
All
Yeah.
right.
And
So,
that's really nice. Yeah.
yeah. All right. So we've been going along, finished the conversation. Last thing before I let you go, you've been doing this a long time, right? 40 years in the database industry. What would you recommend for people that want to get better at working with data and learning? Like a book, a process, protocol? What would you say for somebody like you've got a nephew, you've got a grandkid, somebody they want to get into data? What would you say? Like how would you give them
Yeah.
advice?
If they're just coming from the beginning, I would say get a real simple introductory book like SQL in 24 Hours was my one. I
Mhm.
don't even know if it's still published today, but there's lots of them out there. Real basic introductory SQL book because you'll learn relational by accident. You'll learn because SQL does relational theory, but it doesn't do theory, right?
Right.
So you don't have to read the EF Cod or all the other relational books that I've read. I love those. I'm a theorist, but
Yeah.
you just can do SQL, and all of a sudden, it is simple. It's a simple language when you in the beginning, until
Yes.
you get until you get advanced. So you get to know data through SQL. I think it's a great way to start. Um, and then I would, after you do SQL for a while, I do recommend looking at a good JSON API because that
Okay.
opens your eyes to nested data and object data because JSON is JavaScript object notation and
Yep.
developers use objects for everything. That's why they like JSON because their data is objects now, their code's objects. It works. SQL data is not objects. And
No.
so they have to do a lot of work to convert between the two. So a good JSON database will open your eyes to that world of objects, and then you can graduate from that into the hybrid databases like a FairCom or Postgres or somebody who has good SQL and good JSON,
Okay.
and then bring the two together because I found that is nirvana when you have the power of SQL and the power of JSON in the same database over the same data. Um, the things you can do is just so much more easy and powerful. You start doing some real simple things like every time I design a table now, I add a metadata field that's a JSON field to it,
Uh-huh.
and I index it with the full text index. And because full text indexes work beautiful over JSON,
Right.
and you can query any key and value because they're right next to each other, and so you can find key value pairs with full text index with no work other than just looking for the two things next to each other. And
Interesting.
by doing that, you can now have users can add anything they want to that metadata, or your application can add anything they want to that metadata. It's fully searchable, and now you, with just one field, have all the power for customizability of the application they ever need in the future, but it's just one extra JSON metadata field. Um,
Interesting. Okay. Good advice. Good advice. All right. Well, thank you very much for joining me, Mike. It's been really interesting. I enjoyed this conversation, and hopefully, we'll hear from you and FairCom DB here in the future. So, thanks.
oh, thank you very much. Thanks for having me on. I really enjoyed it.